Hi everyone, I am Questioner Malta, and for today's video, I will be solving sets of problems under direct current. Okay, let's have number 15 first. The no-load terminal voltage of a battery is 24 volts and the short circuit current is 20 ampere. Find the maximum power that can be delivered by this battery. So first, let's have the given. So we have here voltage of 24 volts, the current 20 amperes. So the first thing that we need to do is to find the resistance. So the formula in finding the resistance, we have here R is equals to V over I. So plug this one into this formula, so we get we have 24 over 20, so we get 1.2 ohms for the resistance. So the next step is to find the current. So in maximum power transfer, the formula in finding the current, we have I is equal to the voltage of the terminal over the R initial plus the load resistance. Note that the R initial and the load resistance are equal. So we have 24 volts over 1.2 plus 1.2. So we will get 10 ampere. So from this, we can now find the maximum power transfer. So by using this formula, so PL is equals to I squared multiplied to RL. So we get 10 squared multiplied to 1.2. So we will get 120 watts. So let's see if we have 120 in our choices. So we have letter C. Okay, so for the next number, we have number 32. A practical current source has a current of 22 ampere. Loading the source with 50 ohm results in a terminal voltage of 390.3 volts. Determine the internal resistance of the source. So for us to further understand the problem, we need to draw the diagram. So this one is the IS, RS, and the voltage of the terminal. So IS is equal to 22 ampere, and the RS is equal to 50 ohms, and the VS is equal to 390.3 volts. What we are looking for in this problem is the internal resistance, but first we need to find the current flowing here in this area, or also known as the IR. So in practical current source, the formula in finding the current is we have IS minus V over RS. So 22 minus 390.3 over 50. So we have 14.194 ampere. So from this, we will be able to find the internal resistance. So using this formula, so R is equals to V over I. 390.3 volts divided by the 14.194. So the internal resistance 390.3 14.194 is 27.50 ohms. So let's see if we have 27.5 choices. It is letter V. Number 49. A bar of copper having a mass of 1.5 kg is to be drawn into a wire having a resistance of 250 ohms at 20 degrees. Determine the diameter of the resulting wire. Assumed density of copper is equal to 8,900 kg meter cube. So we have here formula for resistivity, rho L times area. So we will create one, derive L E over A, and then substitute the L, the L of L, and then finally it will come out so we will use this formula to solve the problem. So first, let's compute the volume. 1.5 kilogram over 8,900 kilogram per meter cube. So we will get 168.539 times 10 to the power of negative 6 ohm per meter cube. And then, let's substitute the value of V to this formula. But before that, let's write the formula for area. And the given resistor is 250 ohms. And the resistivity of copper at 20 degrees Celsius is 1.77 times 10 to the power of negative 8 ohm per meter. That is at 20 degrees. So, let's substitute the given value to the formula. So, R is equals to 250, 1.77 times 10 to the power of negative 6 ohm, 168.539 times 10 to the power of negative 6 meter cube over the formula of the area, 5/4d squared. And then, from this, you can now find the diameter. All we need to do is to arrange this one. So, d squared to the power of 2 is equal to d to the power of 4. So, we will have this a fourth root, square root, then 1.77 times 10 to the power of negative 6 ohm per meter. 168.539 times 10 to the power of negative 6 ohm per meter cube. And then the 250 will be multiplied in this area. So we'll have here 5/4 times 250. So we have here the diameter of 3.729395796 times 10 to the power of negative 4, and then multiply it to 1000. Then we will get 0.373 millimeter, and that is our diameter. So letter A. Okay, so we have here problem number 83. A power station supplies 60 kilowatt to a load over 2,500 feet of 002 conductor copper feeder, the resistance of which is 0.078 ohm per 1,000 feet. The bus bar voltage is maintained constant at 600 volts. Determine the maximum power which can be supplied with the line. So first, do the diagram. So this is 600 volts, and this one is the RL, or the power supply, which is 60 kilowatt. So we have here the load current, and in this part we have the resistance of the copper, or also known as the internal resistance. So we need to find this one. So the formula in finding the internal resistance we have, so we will put 2 here because we have 2 conductor based from the problem. So 0.078 ohm over 1,000 feet multiplied to 2,500 feet instead. So we will get 0.39 ohms. And then after that, we'll find the current. So VT over RC plus RL. Note that RC and RL are equal, so we will back to the problem. 600 over 0.39 plus 0.39, we will get 10,000 over 13 amperes. So by that, we will be able to find the maximum power transfer using this formula. So 10,000 over 13 squared multiplied to 0.39. Okay, so we have here 230,769.2308 watts, but the choices don't have watts, only kilowatts. So we'll divide this one to 1000 to get kilowatts. So we will get 230.769 kilowatts. So let's see if we have 230 on our choices. So it is letter B. Okay, number 66. A circuit contains 6 nodes lettered A, B, C, D, E, and F. Let B, A, B be the voltage between nodes A and B with its positive reference and the first named node, here A. Find BAC if BAB is equal to 6 volts, BCF is equals to negative 8 volts, VEC is equals to 4 volts, BDE is equals to 1 volt, and BVD is equals to negative 3 volts. So, here's the diagram. So for us to find the VAC, let's note her BAB plus BBD plus VDE plus VEC, and then substitute the volts here, the given volts. We have here 6 volts, 3 volts, plus 1 volt, and plus 4 volts. We have here 6, 11 volt minus 3 volts, so we have 8 volt, letter B.